All right, here we go. Moving on to our last section in chapter 4. We're going to be looking at solving equations, but this time we're going to be working with multiplication and division. So you don't have to write this problem down, but I do want you just to write the title, set up your Cornell note style, and then just make sure you're following along and listening. Pause the screen as needed. So here we go. Let's pretend that you have 5 gift certificates to your restaurant that you want to give to your friends. Each card has the same amount. The total of all 5 cards is $250. So I want to know, how can I find out how much each gift card would have? Now I know a lot of you are like, oh, I can take 250 and divide it by 5. And you absolutely can do that. But sometimes it's not going to be as easy as that. And so I want to make sure we understand what's going on. So how you would write this is, I don't know what's on my gift card, so I'm just going to put a C, or I'll make an A for the amount on the gift cards. But I know I have 5 of them, so it's going to be 5 times A. And then this word is, that helps us to know that that's going to be an equal sign. So the total of 5 cards is 250, so that's going to be equal to 250. So to undo, remember our variable wants to be by itself. So I have to divide both sides by 5. So it's going to be 50. But again, you didn't have to write this down. I just want you to kind of get an idea of what we're going to be doing. So, and again, you don't have to write this one down because this was in our notes from 4.6. So remember, it's all about the balance. We want to keep the equation in balance. So whatever I do to one side, I have to do the same to the other. And we want to really look at what operation is being done to the variable and then do the opposite. So remember, addition and subtraction are inverse operation, and multiplication and division are also inverse operations. So let's take a look at solving this equation. Our goal is to get n by itself. It's being multiplied by 6. So to undo that, I have to divide by 6. And I have to do both sides. So 6 divided by 6 is 1. 1 times n is just n. 54 divided by 6 is 9. And then if I went and plugged that back in, 6 times 9 equals 54. That's a check. So let's take a look at this one. -3 is multiplying the variable a. So I need to get a by itself. Since it's multiplication, the inverse operation is division. So I have to divide by -3. And I have to do both sides to keep it equal. -3 divided by -3, that's a 1. 1 times a is going to be just a. 15 divided by -3. Now 15 divided by 3 is 5, but different signs, negative. Don't forget your sleeping integer, man. So it's going to be -5. And again, if I went back in and did a check, so that's -3 times -5, it's going to equal +15. So this is another example. Again, you don't have to write it down. Let's just look at it. So let's pretend you have 4 people at your fabulous new restaurant. They decided to split the bill evenly among all of them. They each paid $22. So I know we can say, oh, we just multiply 4 times 22, and that'll give us our answer. But how would I write that as an equation? So my unknown is the bill amount, the amount for the bill. So I'm just going to put A for the amount of the bill. I'm going to divide that by 4 people. And each of those, that's going to be $22. So notice right now it's being divided by 4. We want to look at the inverse operation. So I'm going to multiply both sides by 4. 4 divided by 4 is 1. So I'm going to be left with A equals 88. So my original bill was 88. So go ahead and you can write this down if you want to have it refreshed in your mind for when you solve your multiplication. But you do have this already in your notes for 4.6. You just need to have a resource that you can go to help you if you get stuck. So it's the same as our adding and subtracting. So we want to use the inverse operation to isolate the variable. Remember, isolate meaning that the variable wants to be alone, doesn't want to be around anybody. Right? And whatever I do to one side, I have to do to the other. And then always check the reasonableness of your answer. So here we go. Let's practice. Again, my goal is to get this variable by itself. Right now, it's being divided by 3. So to undo a division, I have to multiply it by 3. And whatever I do to one side, I have to do the same to the other. Okay. This 3 divided by 3, we can think about that canceling it out to 1. 1 times x is just x. 15 times 3 is 45. Oh, and if I did 45 divided by 3 as a check, that does equal 15. All right, and again, you're going to have these negatives still. That was chapter 3. Again, our goal is to get this variable by itself. What is being done is division, so I have to do the opposite. And a lot of students keep doing the same thing. So they would end up dividing by -2, thinking that that cancels out, and then divide this by -2 and get -5. Okay? But that, if I plugged it back in, then that wouldn't be the correct answer. So again, it's being divided, so I have to do the opposite, which is multiplication. And I want to get rid of all of this -2, so I have to multiply it by a -2. I want to get rid of the whole thing. So that divides out to 1. 1 times a is just a. And if I multiply the left side of the equation by -2, I better multiply the right side by -2. 10 times -2 is going to be -20. And again, double checking the reasonableness of the answer. So -20 divided by -2. If I just did my normal division, 20 divided by 2 is 10. Same sign's positive. All right, here we go. A couple more examples. So I'm going to isolate this variable. What's being done is multiplication, because remember, when a number is right up against a variable, it's multiplication. So I have to do division to get rid of it and divide on both sides. 8 divided by 8 is 1. 1 times g is just g. 88 divided by 8 is 11. And if I did a check, 8 times 11, oh, that's 88. Okay, and again, our variable wants to be alone, so it's being divided by 3. I need to multiply it by 3. And if I multiply the left by 3, the right by 3, I better multiply the left by 3. And so B is going to be happy. He's like, woohoo, I'm by myself. And 3 times -25 is -75. And if we went back and I did a check, -75 divided by 3, it's going to give me -25. Check. So I know this reciprocals, reflipicals keep coming back, and it's going to make it a little bit more difficult, but I think you'll get it after some practice. The main examples that we did are going to be the primary ones that you want to focus on, but this is just kind of taking it to another level. So a reciprocal, or Danica likes to call it a reflipical, is when you take two numbers, you multiply them together, and they're 1. So here's an example. If I took 3/4 and I multiplied by 4/3, 3 times 4 is 12. Now I can just write it over here. And then 4 times 3 is 12. Oh, look, 12 divided by 12 is 1. So I know, and you're like, it's hard enough as it is. But let's just really think about what's going on. This R wants to be alone, so I'm going to box him. He's being multiplied by right now by a 4/5. So to get rid of that whole 4/5, I want to change him to a 1. I don't want to change it to 0 because then that would be get rid of the r as well. So I'm going to multiply him by his reciprocal, the reciprocal. So 4/5, the reciprocal is 5/4. Notice I just switched the order. And if I multiply the left side of the equation by 5/4, I better multiply this right side by 5/4. He's going to be mad. He's going to be like, what? That's not fair. 5 times 4 is 20. 4 times 5 is 20. 20 divided by 20 is 1. So these guys cancel out to 1. And I'm left with r. And again, he's happy because he's all by himself. Now, I know a whole number times a fraction. You got to make it look like a fraction. 20 times 5 is 100. 1 times 4 is 4. 100 divided by 4 is 25. And if we went back and double check, so that's going to be 4/5 times 25. You're like, a fraction times a whole number. Make it look like a fraction. 4 times 25 is 100. 5 times 1 is 5. 100 divided by 5 is 20. Oh, look, that's what we had over here, was that original 20. Okay, a couple more examples on this, and I think you'll get it. First thing I want to do is box him, and that just kind of highlights that I want him to be by himself. So it's being multiplied by 4/3. I'm going to multiply by the reciprocal. Again, notice all I did was switch the order. And I multiply this side by 3/4 because he's going to be mad. He's going to be like, why does he get multiplied by 3/4 and not me? So this divides out to 1, and I'm left with m equals 12 times 3/4. And you're like, a whole number times a fraction. Well, we need to make this whole number look like a fraction. And we can. 12 times 3, 36. I did the 3 times 2 to get 6, and then 3 times 10, 36. 36 divided by 4 is 9. I know, last one. Woohoo! Here we go. Box this. And again, you don't necessarily have to box it. I just like to highlight which one is being the variable that you want to keep, and which one wants to be alone. So it's being multiplied by 1/2. So I'm going to multiply. I want to get rid of it. So I'm going to multiply by the reciprocal. Notice it's just the reciprocal of this. 2 times 1 is 2. 1 times 2 is 2. 2 divided by 2 is 1. So 1 times c is just c. And hello, you multiply this by 2/1. You better multiply this side by 2/1. 12 times 2, 24. If you want to put them over 1, that's fine. But 1 times 1 is 1. And mathematicians want to be efficient, so they're going to get rid of this guy, and they're just going to say 24. And 1/2 of 24 is 12. Woohoo! And you can always go back and do that check as well. So we'll practice. Don't stress.